In this lab, so what we did was that we imported the time series data on public transport network across Auckland, and we prepared the data. We created a new column for year and a new column for month, and then we explored the data using line plot and box plot, and we found that for the trend there was a linear trend up to 2020, and then um, there was a decrease after 2020 because of the COVID lockdown. So the number of passengers tremendously declined when there was a COVID lockdown. Then we also plotted, so in the line plot for every year, we found out that for 2021 and for 2020, the number of passengers, it decreased for April in 2020, and around September for 2021. And plotting the box plot, we found out what we found out from the year-wise box plot. The trend was a linear increasing in increasing order. So the number of passengers was increasing, and but when there was a COVID lockdown, the number of passengers declined. The median number of passengers was the lowest in 2022. Looking at the month-wise box plot, it gives us the seasonality. The seasonality for December and January, the number of passengers was quite low. It was one of the lowest in January. The median was lowest. And then in this lab, we will look at the patterns in time series data. Any time series may be split or decomposed into the following components: trend, increasing or decreasing slope over time; seasonality, distinct repeating pattern at a temporal frequency, could be hourly, daily, weekly, weekdays, or weekends, etc. Not to be confused with cyclical behavior, which won't follow a temporal pattern. Residuals or error or randomness. So there are three components. So residuals or error or randomness, seasonality, which is distinct repeating pattern at a temporal frequency, could be hourly, daily, weekly, weekdays, weekends, monthly. Trend, increasing or decreasing slope over time. Not all time series will necessarily have a trend or seasonality though, or could even have one and not the other. We will look at our Auckland transport data and carry out a classical decomposition by considering the series as an additive combination of base level, trend, seasonal index, and the residual. The different tools in stats models. Spelling of different is not right, so we will correct that. The different tools in stats models are ready for doing this. So seasonal underscore decompose in stats models. STL is seasonal decomposition using LOS. So to get more information on LOS, we can click on https:// dev-slash-decomposition.html. So let decompose equal passenger data, and by putting the double square bracket, we are forming a data frame. So we are forming data frame of month, year, and passengers in thousands. And then a dot set underscore index of month dash year will be setting the column month dash year as the index, and printing the data frame. We can see that month dash year is the index, and passengers thousands is the column. So from states models .tsa.seasonal, import STL. We look at STL decomposition. Let outcome equal STL of decompose dot index location bracket square bracket colon comma 0. So this will give us the values in the first column, in the passengers thousands columns. We can either do that, or we can we can also put here the column name. So passengers in thousands. So instead of dot index location colon comma 0, we can put passengers thousands, the exact column name, and dot fit open and close bracket. plt.rc params dot update of bracket, and then we'll put a curly braces to form the dictionary of parameters. Figure dot fix size colon is width equal 10, height equal 10. Close the brackets. Outcome dot plot open and close bracket dot subtitle open bracket. So subtitle we want HTL, and the position is x equals 0.15 and y equals 0.95. Font size equal 14, that's the size of the letters, and color equal red. plt.show open and close bracket. So if I run that, I get the observed value, passengers thousands, these are the observed value, and then I get the trend. So we can see the trend, it increases and then decreases. And then we look at the seasonal. So seasonal, looking at the seasonal, we see that seasonal. So yeah, so we have 2005, 2006, this is 2008. So seasonal pattern is we can see is repeating. There is a cycle every year. Every year we see the cycle until this particular year over here, and this year represents 2021, 2022 and onwards. Yeah, so there are change in patterns. And the residual. So residual is similar. That is the estimated number of passengers, and the difference between the estimated number of passengers. from the model, and the observed number of passengers. So from the exact values minus the model values, we get the difference, and we can see that it's around 0 for up to 2019. And something happened after 2019 that the difference has been decreasing, and also there is an increase sometime, and then there is a decrease. From states models .tsa.seasonal, import seasonal underscore decompose. Let's look at the additive decomposition. Let result underscore add equals seasonal underscore decompose of decompose data frame. So the data frame that we formed, that is decomposed data frame, which is this one. And the passengers in thousands column. Model equal additive, extrapolate underscore trend equal frequency. So frac, which is for frequency. plt.rc prums.update of open bracket and the Kelly braces for the dictionary of parameters, figure.fixsize colon bracket width equal 10, height equal 10. Result underscore add dot plot open and close bracket dot subtitle of seasonal decompose, comma, the position is x equals 0.2, comma, y equals 0.95, comma, font size equal 14. So the size of the letters equal 14. Color equal red. plt dot show open and close bracket shows so that shows the observed value for seasonal decompose. So we can see this. These are the observed values, the actual values, and this is the trend. So it's a linear trend, but then it shows that it's going down after 2020. And for seasonal, we can see that every year there is a cyclic pattern. And this is the additive model, seasonal additive model. And residual shows that it's mostly 0 up to 2019, and it started increasing and decreasing, that is getting away from the 0 line after 2019. Discussion points. So the key differences. So the key difference between the additive model, seasonal decompose, and HTL. So what are the key differences? Let's see if we can see some key difference. So these residuals are very small. Let's look at these values. So these residuals are a bit high. These are below minus 4,000, and one value is below 4,000 and the other value is above minus 4,000. So the key difference, if we look at the seasonal pattern, the HDL decomposition gave us that after about 2021, it showed a bit of different seasonal variation over here. But seasonal decomposition, the additive model, doesn't show that difference. So there is a difference between in the seasonal decomposition for HDL and the seasonal trend, the seasonal for HDL decomposition and seasonal decomposition of additive model. But what about the trend? Looking at the trend, let's see if that shows some difference. No, it looks similar. So only difference is in the seasonal, and the residual there is a bit of difference as well, but the pattern is similar. Want to avoid patterns remaining in the residual time series? If there is, may want to consider model equal multiplicative. So if there was some kind of pattern here, if there was some kind of pattern, then we would use another model, and we'll use a multiplicative model to look at to decompose the observed value into trend, seasonal, and residual. And the observed value equal trend values plus seasonal values plus the residual. We will continue with this lab in the next we will continue with this in the next lab.